Hello and welcome. Are you somebody looking to achieve one of the highest grades possible in GCSE maths? If you are, then please continue watching this video, as today we aim to tackle the topic of exponential growth and decay. Now, if you've seen some of our other videos, you'll be well aware that we will always call upon prior knowledge and previous understanding, and this video is no different. To be more precise, we will be calling upon your knowledge of compound percentages. You may have heard of compound interest previously, and this session will certainly develop that idea. But please, if you are looking to achieve one of the highest grades possible in GCSE maths, then continue watching. Without further ado, let's crack on with question 1. Question 1 then. A radioactive sample has mass 400 grams. It decreases by 7% every day. Find the mass after 12 days. Well, if we're losing 7%, we'll have 93% left. So if we take our starting mass of 400, we'll have 93% left. So that's 0.93 using the multiplier method. And our time frame is measured in days. So that will be to the power 12. You'll certainly need use of a scientific calculator for this video. So let's type in 400 times, open brackets, 0.93 close brackets, to the power 12, execute. The mass after 12 days, 167. I always give my answer to 2 decimal places unless told otherwise. 0.44 grams. Let's move on to question 2. So that first problem would be exponential decay because the starting amount is reducing. Goes without saying, I'm sure, but just to add that clarity. Question 2. A population or a town has population of 18,000. It grows by 2.5% each year. Write an expression for the population after n years. So we're not looking for a final numerical answer. We're just looking to be able to write an expression so that the population can be worked out after however many years. So let's take our starting value of 18,000 times our percentage growth, exponential growth, is 2.5%. So using the multiplier method, that would be 1.025 in brackets. And our power always gives us our time frame, n years. So to the power n. And that is it. We haven't got to work anything else out. We're just writing the expression. Let's take a look at question 3. A machine loses 12% of its value each year. After 6 years, it is worth £3,400. Find its original value. So if we take this original value to be x times, if we lose 12%, we have 88% left. The time frame, the power, would be 6. And the final value is 3,400. So to work out the original value, x, we need to do 3,400 divided by 0.88 to the power 6. Therefore, x equals, and I'll just get my units ready for the final answer. Certainly going to need a scientific calculator. 3,400 divided by, open brackets, 0.88 close brackets, to the power 6, execute, and I'm getting £7,321.21. Now, unless stated, I always give my answers to 2 decimal places, but given that this question relates to money, even more importantly, I'm giving my answer to 2 decimal places because we work in pounds and pence. Let's take a look at question 4. And remember, as always, we start at a relatively low level in each video and then gradually build up the difficulty as we move through our 4 questions. Here we go. A rare species of plants has an initial population of 5,000. For the first 4 years, it increases by 6% per year. After this, disease causes the population to decrease by 9% per year for the next 5 years. Find the population. I'm going to do each question one at a time. I'm not even going to read questions 2 and 3 at this stage. So, for question 1, we want the population after 4 years. So I take my starting value, 5,000, like so. It increases by 6%. So using the multiplier method, that would be 1.06. And our time frame is 4. Now it's saying give answers to the nearest whole number where appropriate. Well, let's see where we get to initially. Typing into my calculator, 5,000 times open bracket, 1.06, close bracket, to the power 4, execute. To the nearest whole number, I'm getting 6,312 plants. Like so. Question 2, and I'll just do this in a different colour. After this, disease causes the population to decrease by 9% per year for the next 5 years. What's the population after 9 years? Well, this time our starting value is 6,312. If we're losing 9%, we have 91% left. So our multiplier will be 0.91. And that's for the next 5 years. Let's see where we get to. 6,312 times, open brackets, 0.91 close brackets, to the power 5, execute, 3,939 plants. And again, I'm rounding off to the nearest whole number because that is what the question has stipulated. Question 3. Again, I'll do this in a different colour. The overall percentage change from the original population. 2 ways of doing it, but I'm just going to, in my opinion, do the easiest way. Percentage change is the difference divided by the original times 100. So our difference will be 5,000 subtract 3,939. I'll put that in brackets. All over, in fact, let's get this looking neat. Our original value, which was 5,000, times 100. So let's type it in. 5,000 subtract 3,939 divide by 5,000 being our original times 100. Change the format of my answer. I'm getting a 21.22% reduction. I think it's important to include that key word at the end. We know it's a reduction because we started at 5,000 and we're now at 3,939. You may have found out your difference the other way round by doing 3,939 subtract 5,000, in which case your answer would have been minus 21.22%. So you wouldn't need that keyword because the negative symbol at the start of your answer would obviously indicate a reduction. Now, we always say that if we have touched upon any topics in this video that you think you might need further support with, please check out our other videos. But for now, the very best of luck in your quest to achieve one of the highest grades possible in GCSE maths. And thank you for watching.